Welcome back, grade 7. You are back at Maski TV with Teacher Nesipo. And today we'll be working on decimal numbers. Now, under decimal numbers for today, we'll only be focusing on the introduction of decimal fractions. Let's dive right into it. And now, at the end of this lesson, I want you to be able to define what decimal numbers are and revise the whole numbers. And also distinguish between number places, which we mean the basis of 10 of whole numbers, distinguish between number places of decimal fractions, and also be able to order and compare decimal numbers. Let's dive right into it. Firstly, the definition of a decimal fraction. Decimal fraction is a convention used to represent numbers that are smaller than 1 and can be extrapolated. Remember, we worked with whole numbers. Whole numbers are numbers that starts from 0 and goes to 1, 2, 3, and so on and so forth. Those are what we call the whole numbers, which are the counting numbers starting from 0. If whenever you count, you start from 0, you say 0, 1, and so on, those numbers that you are calling out are actually what we call the whole numbers. Now, we also know that we can have a half, and a half is a number that is less than 1. So when we are talking about numbers that are less than 1, we talk about decimal fractions. Decimal fractions are numbers that are used to represent numbers that are smaller now than 1, rather than what we've been working with, which is whole numbers. Now, on decimal fractions, we use a system for counting which is called the base of 10. So whenever we are calculating numbers, whole numbers, we use the base of 10. The system that we are using, we call it a base of 10. Now, what do we mean by that? And what we mean by that is the number places. Now, what do we mean by that? Number places basically means whenever I give you a number, which is 376, the number 376, we know from our number places with when we were working with whole numbers, we had this first value as being the units. We used to call it the units, and the other textbook, they call it the ones place. What does that mean? We call it the ones place because the numbers we have used under groups, the numbers we have used in whole numbers, we call those numbers a base of 10. So the first digit that we have in any whole number that we have, we call it, it's in the ones place. The ones place basically refers to the box which falls on the first value, the very first value of your whole number. Now, we also have the second box on 376. This second value, we call it, it's in the it's in the group or the box of tens. And on other textbook, it's only represented by the capital letter T. Now, this 300, that means we have 3 of hundreds. So we call that group the place of hundreds. Hence, we are calling it the place of hundreds there. And if we had 1,376, this place, it means we have 1,000. So that means this place, we'll call it the thousands place. Hence, we are saying it's a base of 10. How did we get to the base of 10? Naming this as being ones, tens, hundreds, and thousands. We said we had the first group as being the ones, and then multiplying that 1 with a 10, you get tens, which we mean by that second value. Now we multiply that 10 by another 10, we get the hundreds. And then we multiply the hundreds by another 10, we get the thousand. And then multiplying the thousands with another 10, you'll get the 10,000s place. Those are all the groups or the number places that we usually use on whole numbers. Now, here I was just explaining what we are having here, which is the 3 on 360 is the hundreds, and then the 7 is the tens, and then the 6 is the ones. And for this, I will be using the first value. Instead of calling it units, I will call it the ones place. Okay, now the number places for decimal fractions. Now, these were all 1,376. That was a whole number, right? Remember, whole numbers are all the positive whole numbers, including 0, when you are counting. Now, this was a whole number. Now, I'm telling you that decimal numbers are numbers that are used to represent numbers that are smaller than 1. Now, remember, we had the ones place, we had the tens place. Now, for numbers that are smaller than, using the 1 as our neutral zone. The numbers that are smaller than 1, we had a tens on the left-hand side of the 1. Now, on the right-hand side of the 1, it will be the 1 over tens place. The 1 over tens place, we call it the tenths. And then we divide. Remember, when we were looking for these places, we said 1 times 10, and then we got the tens place. We said 10 times 10, we got the hundredths place. Now for the decimals, which is numbers that are smaller than 1, we divide. Instead of multiplying now, instead of this multiplication by 10, now we will be doing what? We'll be dividing by 10 to get the decimal places. Now, this 1 over 10, if you divide it by 10, you will get the hundredths place. It's the hundredths place. And then, after that, you divide that by 10, you will also get the 1,000ths place, which is the thousandths place. Now, the numbers that are on the right-hand side of the 1, which is our neutral zone there, the numbers that are on the right of it, we call it, there's always that THS at the end. There's always that THS, which is used to represent that these numbers, they are small numbers than 1. Now, what separates the whole numbers? The number places for whole numbers. What separates them, these whole numbers, which is 1, tenths, and hundredths, what separates them from the decimal parts? What separates them from the decimal parts, we use what we call the decimal point. The decimal point is a dot used to separate the ones place, which is that. We're separating this from the 10th place. So to separate the whole numbers and the decimal numbers, we use what we call a point. And that point, we're going to call it a comma. That point, we're going to use a comma for it. So this means if I have a number that is 2,346, can you see that there is a comma there? Can you see that we have a comma there? That means 2,246, that is my whole numbers part. And then on the right of it, just after the comma, I have my decimals. And then how do you read decimal fractions? The whole numbers part, you are reading it in the same way you've been reading it, which is 2,346, comma. Now instead of saying point, now we are saying comma. You won't say 2,346.718. You will say 2,346,718. And yes, you read it like that. You can't say it's 718 there. The numbers after the comma, we are calling them individually. So this will be 2,346,718. From there, let's go to, now that we know what decimal numbers are basically a combination of the whole numbers and the numbers after the comma. Now, from there, this means we can be able to compare, in the same way that we're able to compare whole numbers, we can be able to compare decimal fractions. But how do you compare decimal fractions? Here's how. To compare decimal fractions, here's the first step. To compare decimal fractions, The first step is to write them with the same number of decimal places after the comma. That means if I have a 1,2 and a 1,13. Here I have how many decimal places? I have 1. And then here I have how many decimal places? I have 2 decimal places. So in order for me to compare these two numbers, I need to have the same number of decimal places. But how do I make 1,2 to have the same number of decimal places as 1,13? What we do is, it says we add the zeros onto the decimal fractions with the least number of zeros or decimal places. So the least number means the smallest number of decimal places. Here I have 1, here I have 2. So that means I need to add a 0 on the right or at the end of the last decimal that I had. Now I have 2 decimal points, now, and there I also have 2 decimal points. Now I can start to compare my 2 decimals. Now step 2 says you can compare the number ignoring the comma. Now it says, now that I have 2 decimals there, I can just compare the 2 numbers without checking the comma. That means I can interpret this 1,20 as just 120 against this 1,13 as just 113. And now we are back to whole numbers, which is what we do best. Now, between 120 and 113, which one is bigger? The bigger one will be 120. But now remember, we were working with decimals here. We had a comma right there. We had a comma right there. So that means 1,20 is greater than 1,13. Now, remember when we are comparing numbers, we use inequalities. And we did work on inequalities. We said we had the less than inequality and the greater than inequality, and also the equal sign, which means those 2 numbers are exactly the same. Now, remember we said for inequalities, the one that the inequality is opening to, that is the bigger number. So here, between 1,20 and 1,13, my inequality will open into the bigger one. And I even told you that on my past examples and my past videos. I said you can look at the distance. The distance here is bigger than the distance which is there. So that means the number on this side is bigger than the number on the right-hand side. So here, in order to compare these 2 numbers, I will use the greater than symbol. Let's see if we have some examples for you. Here are examples for you. It says compare the following decimal fractions by either writing the less than, the greater than, or the equals to sign. Here, we have 7,426 against 8,273. And that is how you read it. You read it as 7, comma. You don't read it as just 7 point. It's 7,426. And this is 8,273. Now, we need to compare these 2 decimal fractions. Now, to compare these 2 decimal fractions, we just ignore the comma. If you ignore the comma, this will be 7,426. And then this will be 8,000. Which one is greater between 7,000 and something and 8,000 and something? It's 8,000 and something. So that means my inequality sign will be opening to 8,273. So that means my solution there will be a less than symbol. And then we have B. B says we have 6,25 against 6,35. Now, how do we compare them? We ignore the comma. We just say 625 compared to 635. 625 and 635. So 30 is obviously greater than 20. So here, my inequality sign will still be opening to the bigger number, which is 6,35. C. C is an interesting one now. It says we are comparing 1,7 into 1,599. Remember our steps. The first step says you must get your numbers to have the same number of decimal places. But now, here I have 3 decimal places, and here I only have 1. Now, what did it also say? It said if you have a deficiency in the number of decimal places, you can extend it by putting the zeros on the right-hand side. Now I have 3 decimal places and I have 3 decimal places. Now I can start comparing my numbers. Now I have 1,700, I have 1,599. To compare those, we just ignore the comma and say 1,700 compared to 1,599. 1,700 and 1,500. Obviously, 1,700 is greater than 1,500 and something. So that means my inequality will be opening to the bigger number. That means it's opening to 1,700, which is, in our case now, it's 1,700. So that means 1,7 is greater than 1,599. That was number 1. Number 2 is asking us to arrange these numbers in descending order. It's asking us to arrange these decimal fractions in descending order. Now, which number? Remember, we have ascending and descending orders. Now, which number comes first between A and D? Which letter comes first? It's A. So in ascending order, we start from the smallest number because it comes first and goes up. Descending means D comes after A. So that means we're starting from the big number going down. So here we have the numbers 24,299, 2,349, 2,111, 24,107, 24,346. Now, the first thing we do, we first check the first step, which is, are we having the same number of decimal places? I have 3 decimal places, 3, 3, 3, 3. Nice. That means I can start comparing because I already have my decimal places being the same. Now I have, remember, to compare the numbers, you just ignore the comma. And you need to bear in mind that when you are separating numbers, you are separating them with a semicolon. Yes, separating them with a semicolon, not with a comma. We are separating them with a semicolon. Now, here we have 24,299. Now you just compare the numbers by ignoring the comma. Now this is 24,299. Remember, we want to start from the big number going down. So I have 24,000 and something. I have 2,000 and something, 2,000 and something, 24,000 and something, 24,000 and something. Now, we first, if we are starting to compare the numbers from the biggest going down, we need to first focus on the 24,000 and something number, which is 24, something here. That means we'll compare this one, that one, and that one first. Here I have 24,299. Here I have 24,107. Here I have 24,300. So this one is obviously bigger than these two. So that means that will be my first number, which is 24,346, separated by a semicolon. Now I need to compare these two, the remaining two. These two I have 24.2. Here I have 24.1, which means that 24.2 is bigger. This will be 24.299. Remember, you don't say point, you say comma. Next, and then the last one would be amongst the 24 comma something, it will be 24,107, semicolon. Now we need to compare the remaining two, which is that and that. We have 2,349, 2,111. Remember, when we're comparing them, we just ignore the comma. This is 2,349. This is 2,111. So 2,300 and 2,100. So 2,300 is bigger. That means here the next number will be 2,349. And the last number will be 2,111. That is how you were to arrange those numbers in descending order. Remember, descending order means starting from the biggest going down. Now let's go to B. B is saying, let's compare these numbers. The first thing you check, are we having the same number of decimal places? Here we have 1 decimal place, 2 decimal place, 1, and 3 decimal places. So the one with the least number of decimal places is 1. So that means we will add 0, 1. From that one, we will add 2 zeros because we want it to have 3 decimal places. 0, 0, 4. It has 2, so it needs 1 more. We add 0 there. This one, 1,6. It has 1 decimal place, so we add 2 zeros more. This one, it's 0.002. It already has 3. Now, all of them has 3. Now, remember, when you're comparing numbers, you just ignore the comma. This will be 100. This will be a 40. This will be 1,600. And this will just be a 2. So which number is bigger? It's the 1,600, which is 1,600. The next one will be 100, which is 0,100, which is, the next one will be 40, which is 0.040, and then the next one will be 0.002. Now remember, you were not given these numbers. These are the numbers you were given, so you can go back and write them. This will be 1.6, 0,1, and this will be 0,04, and this will be 0,002. Those are all the numbers arranged in descending order. Now, this was me working with you on these examples. This is for you now to go and do it at home. I have this homework for you. Please do engage with the homework and like and also subscribe and ask questions on the comment section. We'll gladly answer your questions there. Remember, we have our Maski to assist you with our homeworks. And the number is 072-091-0388. And till we meet again next week when we will be doing part 2 of decimal numbers, where we will be focusing on calculation techniques, adding, subtraction, division, and multiplication of decimal fractions. And thank you. See you again.
Chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.